Hi, today we're going to take a look at how to use square root property to solve quadratic equations. This is going to be the second method that we're going to talk about with factoring to solve quadratics being our first method. This means that there are two solutions when taking the square root of a term, as in the example that we did earlier is that whenever you have, for example, x squared minus 25 equals 0, you add 25 to both sides, and then when you take the square root of it, it's not just 5, it's 5 and negative 5, because if I square negative 5, the answer is also positive. And quadratics usually intersect the x-axis at 2 points, so then the plus and minus represent the two solutions where they would intersect the x-axis. So if we take a look at our first example, we have x squared equals 36. We just take the square root on both sides, and your answer would be plus or minus 6. In example number 2, we're going to divide by 5 on both sides, then take the square root of it. So the square root of 5 would be square root of 5, and then because we took the square root, it would be plus minus square root of 5. On example 3, this is a two-step equation. We have to get rid of all the extra terms that does not have your variable in it. So notice that 2 does not have the variable x in it. So we got to get rid of the 2 first by subtracting it on both sides. Then we divide by negative 3 on both sides to get x by itself. So now we take the square root on both sides. So we have plus or minus square root of 24, and then we have to simplify it. So 4 and 6 are factors of 24. Square root of 4 is 2, so it'd be 2 radical 6, plus or minus 2 radical 6. Now in these next four examples, you'll notice that they have a binomial being squared versus just x being squared. Now square root property says anything that's being squared, if it's a binomial, if it's a monomial, any time that you have something squared, you can take the square root of it to get rid of whatever is being squared. So in our case, example number 4, we're going to take the square root of x minus 1 quantity squared, and we're also going to take the square root of 16. So once we take the square root, we get x minus 1 is equal to plus or minus 4. Now because there's no variable in this, there's no I, there's no radical, then we are going to have to actually solve for what those two missing numbers are. So we're going to go ahead and add the 1 to both sides, and when we do that, it comes before the plus or minus sign, and the order does matter because it's going to change your final results. So to finish off number 4, we have 1 plus or minus 4, but now we have to separate it because there's no variable, so you get 1 plus 4 is equal to 5, and 1 minus 4 is equal to negative 3, and then those would be our two solutions. In example number 5, you'll notice that this is the part being squared, the x plus 4. Everything in parentheses being squared is what we want to isolate. We're going to keep the x and the 4 together, and we get rid of everything outside of that box. So we're going to divide by 3 on both sides, so we get x plus 4 quantity squared is equal to 10. Now you can see that there is nothing else that is being squared. So now we are ready to take the square root on both sides. When we do that, we get x plus 4 is equal to positive or negative square root of 10. And there's one last step to get x by itself, and that would be to subtract 4. And any whole number gets written before the plus or minus sign. In example 6, that one's a little bit different than 5, is because in 5, you had a number being multiplied by the binomial being squared. In number 6, you have something being added to the binomial being squared. So we go back to how we solve equations, and we subtract any number not with x in it on both sides first. Then we can take the square root. And when you take the square root on both sides, you get x minus 5 is equal to plus or minus the square root of 44. Remember, 44 has a perfect square of 4, so you'd break that down into square root of 4 times the square root of 11, and the square root of 4 is 2, so it would be plus or minus 2 square root of 11. So once you break it down, again, you get x minus 5 is equal to plus or minus 2 radical 11. The last step is to get x by itself to be by adding 5, so you'd get x equals 5 plus or minus 2 radical 11. Our last example is where we kind of put all of examples 4 through 6 together in one go. So example number 4 is just the basic, hey, here's a binomial being squared, take the square root of it and simplify. Example 5 says, hey, look, we have a number in front of that binomial squared, so you're going to divide it out and then simplify. In number 6, it says, hey, look, we have something being added or subtracted to that binomial being squared. Get rid of it, then you can simplify. In number 7, notice that you have a number in front of the binomial being squared that you would want to get rid of, and then also a number being added or subtracted after the binomial squared that you're also going to have to get rid of. Now, order does matter when you solve an equation. So if I have 2x plus 4 is equal to 60, then you'd want to subtract the 4 first, the part that doesn't have a variable, then do your dividing at the very end. So in example number 7, we're going to subtract the 4 first. So we get 2 times the quantity of x plus 3, quantity squared, is equal to 56. Then I divide by 2. Now that you have the binomial squared by itself, now we're back to example number 4. We can go ahead and take the square root on both sides and simplify the square root of 28. So we get x plus 3 is equal to plus or minus 2 radical 7 when you simplify the square root of 28. And now the last step is to get x by itself. So you subtract 3 and you get x is equal to negative 3 plus or minus 2 times the square root of 7. So you get, again, negative 3 plus or minus 2 radical 7 in solution 7.